So, good morning, everyone. Welcome to my tutorials today. My topic is Casper Basics for New Users. I am Xuquan Su. I am from Consulting Service Group. Let's start from some housekeeping items. Thank you for joining us today. Here's a few things to note before we really get started. The presentation is being recorded and will be available on the CISL website within the next few days. If you have questions, please enter them in the chat. We will answer all the questions at the end of the talk. Please keep your computer or phone audios muted. So here are the topics we will cover today. First, we will talk about the Casper hardware's two types of nodes for different tasks. Second, we will talk about accessing Casper nodes using our Slurm scheduler. Then we talk about interactive jobs, virtual remote desktops, machine learning, deep learning resources on Casper and Jupyterhub. Finally, we will talk about using the GPU capabilities on Casper. So here is the overview of Casper hardware. Casper is the latest data analysis and visualization platform at CISL. We provide modern Intel Xeon architecture, large memory, and OpenGL rendering. Some of the Casper nodes equipped with NVIDIA GPUs for visualization, domain science model simulation, and machine learning, deep learning, neural network. We have quite a few state-of-art NVIDIA Tesla V100 cars. There are mainly two types of nodes on Casper, which we can use for various workflows. The first type of node is data and analysis and visualization nodes. We have 22 of them. They are super workstation nodes. On each node, we have 384 gig memory, and we have two 18 cores, Skylake-like processors. And we have solid state disk, we have Matlab interconnect, we have 10 gig dual port Ethernet to connect between nodes. 9 among these 22 nodes equipped with one NVIDIA GP100 GPU. It's for general graphic usage in data analysis and visualization jobs. Another 13 nodes have no GPU. It's best used for handling large memory footprint process. The other type of Casper nodes is for machine learning, deep learning, accelerated scientific model simulations. We have 6 of them. They are super server nodes. On each node, we have two 18 cores Skylake processors and solid state disk, Matlab internet, and 10 gig dual port Ethernet. 2 of these nodes equipped with 4 NVIDIA Tesla V100 GPU with 772 gigabyte memory. 4 of them equipped with 8 NVIDIA Tesla V100 GPUs. We have 32 gig device memory on each GPU, and we have 1K GB host memory on the node. So it's best used for highly parallel multi-GPU workflow. On these nodes, if you do the math, 32 times 8, we have 256 gig device memory. Those device memory are really fast. And we have the device host memory ratio at 1:4, which is very optimal for scientific simulation. These nodes are very powerful compared to those normal HPC node with like 64 gig memory and 32 core CPU. So here are some general information for all Casper nodes. On Casper, on the DAV cluster, we use the existing DAV environment modules. The modules are not shared with Cheyenne. So you have the Cheyenne module for Cheyenne, you have the DAV module for the DAV Casper cluster. Some of the key module commands are module list, module away, module spider, module help, module show. Generally, we suggest you compile your code on the same system you will use to run on. You compile on Casper if you want to run on Casper. You compile on Cheyenne if you want to run on Cheyenne. For storage, on Casper, we can access the GLAY file system, the campaign storage system, and the HPSS. The operating system on Casper is CentOS 7. The Casper nodes can be accessed through either the Cheyenne login node or the Casper login node with the same NCAR user account. There are two dedicated login nodes on Casper, Casper 26 and Casper 01. So here we talk about the solid state local disk. On each node, we have 2 terabyte solid state storage. Some of them is used to augment the memory, so you are less likely to run into the problem that your job failed due to using too much memory. And the Casper jobs can also access these solid state storage during the job in the following path: local scratch, $Slurm job ID. But please be careful, when the job finish, the data stored in this local solid states will be deleted, and it's deleted for good. There's no way to recover them. Next, we talk about the HPSS and the campaign storage. The campaign storage file system is mounted on the Casper and can be accessed in the following path: GLAY campaign. The users can read and write data directly from their jobs to the campaign storage. The HPSS now is close to the end of the life cycle. Currently, it's read-only. The users can submit a batch job to move the data from the HPSS to campaign storage. So this is the section 2. We talk about accessing the Casper resources using our Slurm scheduler. All the Casper nodes are requested through the Slurm scheduler. Slurm scheduler is set up by default after you log into the Cheyenne, similar to PBS. That means you have access to all the Slurm commands like the PBS commands. You can find the useful Slurm scheduler commands at the following path: NCAR, op, Slurm, latest bin. The wait time is up to 24 hours on DAV. The default wait time is 6 hours. We recommend that you request a specific resources or features so the Slurm can place you on the proper node. We want you to request a type of node instead of a special name of the node. So here is some command to handle your jobs in the scheduler. And usually you need to know at least one of those commands, like the Slurm. For example, if I know the Slurm command sinfer, you can do which sinfer. And usually they will give you the path. And you can recognize from the path where all those commands are. So, and then you further do a ls. So now you see all types of Slurm command you can use. If you want to know more about a certain command, you just say man that command. For example, man s1. And you can do the same thing for the PBS. For example, which queues up. In this way, you can find the path containing all the PBS command. Using the same trick, you can also find some other useful commands in this way. And this is some system provide command and some command provided by our group, some wrappers. I use the red color to highlight some of the useful commands. So next, we talk about submit the batch job to Casper nodes using the sbatch command on Cheyenne. So if you are batch users, you start your job script with this line. And then the example on the right shows running on any Casper nodes with 1 core and 6 gig memory. It is a best practice that you set up the temp directory for your job. Also, it is a best practice that you load your modules inside the job script before the executable. You can see that module load NCL command there. Even better, you can put a module list command before your NCL run command. So in your output, you confirm what are the modules you load at the time before you run the NCL command. And finally, you can put a S control command at the end to show the job info. So next, we talk about how to place a job on a specific node type and reserve consumable resources. So there are 2 ways to do that. So I will talk about it one by one. The first one is called -C. It's a parameter for the sbatch command. The -C is called feature constraint. It specifies the nodes must have a certain attributes, and it is non-consumptive. Kind of like you can understand in an opposite way. When you say not consumptive, which means you take the whole node or you don't take it at all. So it also allows the logic operator like the AND and the OR. And the second way to do that is called GRES. The GRES is does not mean GPU reservation. The GRES means generic consumable resources on each node. So if you request these resources are exclusive for you to use during your job script, which means you have multiple job steps in the job script, so which means it's also exclusive for you to use in each job step. And for this part, you can use part of the resources on the node compared to the feature constraint. For the feature constraint, you either take the whole node or you don't take it. But for the GRES, for the generic consumable resource constraint, you can occupy part of the node. And finally, you need to make sure your feature constraint and resources requests agree. For example, if you use a feature constraint to constrain yourself on a GP100 GPU node, and then you use your generic consumable resources to request 2 V100 GPU, then your job obviously will fail because we cannot give you 2 V100 GPUs on a P100 GPU node. So here are the list of the GPU cluster features and the consumable resources. For the features, we have Casper and Skylake, which will be default to every node. And then we have MLX, we have X11, we have GP100, we have V100 for different type of node. For consumable resources, basically they are the number of the GPU. For the P100, you can have 1. For the V100, you can have 1 to 4 on the 4 GPU node. You can have 1 to 8 on the 8 GPU nodes. So you can also check all these features in the command line with the command sinfer. Usually, the most difficult part of this command is the formatting part. You can use the man sinfer command to show the definition of all the parameter. In this example, I put the command in red. For this format, the command will output the following result: the host name, the available features, and the GRES, and the free memory and memory amount. So here are some more useful Slurm commands and parameters. As batch, submit a batch script to Slurm. As a log, obtain a Slurm job allocation. And as run the parallel jobs. So if you submit a job script by S batch, in the background, the system will finish the S-log and the S1 procedures for you. And the next one is execdav except depth. That's a shortcut for a combination of S-log and S1. The next one is sinfer. It will view the information about Slurm nodes and partitions. You can kind of think like they give you the hardware information. And the next one is the SQ. It will view the information about jobs in the Slurm scheduling queue. It's kind of like telling you about the scheduler information, kind of like the software part of the information. And then you have the S control command. It will view and modify the Slurm configuration and the job state, especially for a particular job. For example, you can say S control show job ID. So next we talk about, this is the third section, we talk about running interactive jobs, graphic jobs, and machine learning, deep learning jobs on Casper. So first, the Casper provides a script to initialize the interactive section. It's execdav. Here are some useful parameters: the account for project code, the time for war time, the end task for the number of tasks. By default, we give you one task. You can use one call on that node. In the MPI context, usually the NCAR equals to your MPI size. And then the mem, it allows you to specify how much memory you want to use per node from 1 to 1000 gigabyte. If you do not specify this parameter, by default, the system will give you 1.8 gig memory per core you request. And the parameter constraint, you can constrain what type of node you want to request. Usually it is GP100 or V100 or X11. Here is the example. When you execute the execdav on the screen, we will echo back the actual S-log command and the S1 command you run, and also the path will help you to set up. So next, we talk about using the TurboVNC to run the program with a GUI. So on Casper, a lot of time you need to run a program with GUI. The VNC provides a remote GNU 3 desktop by default. And we have a script command to wrap all these steps up in a single command. So it's VNC server _ submit. Usually you give the constraint and you give your project code. And you can also specify the other type of desktop KDE by the -D KDE. You can reconnect to the VNC section as long as your job survives. Typically faster and more responsive than just use the X11. Also, you need a local client on your machine to use this. You need a tunnel connection from your local machine. There was a step-by-step instruction at the following website. Next, we talk about the machine learning and deep learning resources on Casper. CISL provides several libraries for users' MLDL work. we provide the following Python library. After you activate your MPL Python virtual environment, you will have the access to the following MLDL package: TensorFlow, PyTorch, Scikit, Hoverworld, Keras. You can find more details in the following web page. And next, we talk about how to set up those environments. The MLDL workloads are most likely integrated with the Tesla V100 hardware. So on Casper, when you run the command execdav, you want to put in the constraint -- constraint equal to V100. And after you land on a V100 node, you execute the command module load Python. The current default version is 3.7.5. And then you run the module list. Make sure you have the NCAR env and the Python 3.7.5 modules ready. And then you execute the command NCAR_PYLib. That will activate the default version of the package library. And then you repeat the command with -l. That will check the version of the package library itself. And you repeat the command itself with the -p. It will check all the package versions inside this library. And when you are done, you run the command deactivate to exit this environment. And you can find more information in the following page. So CISL have a group, AIML group. It's the best point of contact for developing further collaboration. And also from David John's personal page, he recommends the following AI/ML learning materials. And next, we talk about Jupyterhub. And we can launch Jupyterhub on our resources, both Cheyenne and DAV cluster. When you want to use Jupyterhub, please avoid using the Safari browser if you are on a Mac. It has the cookie problem. I provide my example with the Google Chrome browser. You need to, on the left page, on the left figures, you can see, you can choose the Casper DAV. And then after input your project account information at the first time, you will land on the Casper node as shown on the right photo below. So when you use the Jupyterhub on DAV and you want to use the Python package library we provide, here are the steps. After you launch your JupyterLab server, you need to refresh your NCAR env module to access the NCAR PYLib. By default, after you land on this node, the NCAR PYLib is not available. So you need to module unload the NCAR env module, and then you module load the NCAR env module again. And then now you have the access to NCAR PYLib. If you want to use the NCAR package library inside other Jupyter instance on Cheyenne, for example, NPL Cologne, Conda environment, or Jupyterhub instance, you can run the following command to produce a user space kernel from the default NPL kernel. The command is NCAR_PYLib -- kernel and put the kernel version there. So here is the last section of my presentation, the GPU capabilities on Casper. So if you want to run a single GPU serial code, you can access the GPU nodes on Casper via the execdav -c GPU and Casper. And you set up the environment by module load CUDA. The CUDA is the most important modules for the GPU capacity. So, and then you compile your code with the compiler provided by CUDA. If it's a C, it's NVCC. And then you run your executable by just type in your executable's name. If you want to run a multi-GPU MPI-aware CUDA code, here are the steps. You access the Casper node by the same way, the EXECDAV, and then you set up your environment. Now you need both the CUDA modules and the OpenMPI modules. So on the Casper, when you want to use the MPI, the OpenMPI performs best with the CUDA. So we recommend you to use the OpenMPI module as your MPI solution. And when you compile the code, if that's its device code on GPU, you use the command NVCC. If it is a host code, the code running on the host and need to use MPI, you use the MPI-CC. And then at the link step, you use the MPI-CC to link both the host code and the device code together. And when you need to run the multi-GPU MPI-CUDA code, here is the example of the job script. So there are a few points we need to pay attention. First one is we use the feature constraint -CGP100 to constrain our code to run on a P100 GPU node instead of request a certain node. And second, these nodes are shared nodes. So in any time, there's maybe more than one users on these nodes. And some potential stumbling points we need to be careful. So the first one is when you're starting a shell with the S1 command, it already used one core. So you want to ask for n+1 core if you want to run a n task from the n task code from your Casper terminal. If you request a GRES setting to S1 when starting a terminal, those GPU resources won't be available for the subsequent S1 command. And the VNC only works on nodes with the X11 feature. So this is the end of my presentation. We have the following support portal. You can go to the link below to ask your questions. And next is the general help page. You can find a lot of useful articles there before you ask the question in the ticket system. And the next is my office phone number. If you have any questions, please call me. And if you prefer to shoot me an email, here is my email address, shikuan@ncar.edu.